Okay, so now we're going to look at problem solving. Okay, starting with strategies for problem solving. Okay, the first thing we want to do is understand the problem. Okay, which means that we read and we reread. Okay, that's super important. When you get to the end, you need to make sure that you're actually answering the questions that it's asking. Okay, so double check, make sure that you're understanding what they're wanting from you before you continue on. Okay, and then we need to choose a variable to represent the unknown. Okay, with that we need to draw a picture if we possibly can. You won't always be able to do that, but if you can, you need to draw a picture. Okay, then after that we want to translate the problem into an equation. Okay, so translate the problem into an equation and solve that equation, followed by interpret. Okay, interpret's probably the least used skill, but it's super important that you check to make sure that your answer is logical as well as mathematically correct. So you want to plug it back into your formulas once you have them set up. Alright, so one thing we need to talk about is consecutive, which is just following one another in an uninterrupted succession, such as 4, 5, 6, 7. Okay, that would be consecutive numbers. Okay, so if x is the first of 3 consecutive integers, express the sum of 3 integers in terms of x. Simplify if possible. Okay, so the first thing we have to do is identify what my first 3 consecutive integers are going to be. So we're going to look at 2 examples at the same time. One has got numbers, the other one's got variables. Okay, so for instance, 7, 8, and 9, those are consecutive integers. They're in a row, okay, so one right after another. To go from 7 to 8, we would have to add 1. Okay, so to go from x to the next consecutive integer, we would do x plus 1, because it doesn't matter where I start. If I start at 5, and this is 5, 6, and 7, okay, to go from 5 to 6, I still plus 1. This is 100, 101, 102. To go from 100 to 101, I still plus 1. So to get from one consecutive integer to the next, we plus 1. And then to go to the one after that, we would plus 2. Okay, so we would add 1 more from where we just were, but that's going to be 2 from the beginning. So from x, I would have to plus 2 to get to the next consecutive integer. And it would continue on in that pattern. If I wanted to go to the 4th consecutive integer, I would do plus 3. X plus 4, x plus 5, x plus 6, I would continue on that way. So then they ask for the sum of the 3 consecutive integers. So if my consecutive integers are x, x plus 1, and x plus 2, okay, the sum of them, we literally just add them. Sum means add. Okay, so I would add them, and then they said simplify if possible. So x plus x plus x is 3x plus 3. Okay, we don't set it equal to anything. They didn't say it was equal to anything, so that's just my answer. There would be the sum of 3 consecutive numbers in terms of x. Remember, that word in terms means that x is going to be part of the answer. Okay, we can also look at consecutive even numbers. Consecutive even numbers, if this is my x, well, to get to the next even number, because if I go x plus 1, I'd be at 9. Well, I don't want 9. I said consecutive even numbers. Okay, so consecutive even numbers would be like, and you might want to add an example here, like 10, 12, 14. Those are consecutive even numbers. So 8, 10, 12, consecutive even numbers. Okay, so we don't want to go to plus 1. We don't want to hit 9. We want to skip that 1 and jump all the way to 10, so that would be plus 2. Okay, and then we don't want to go to 11, so we won't plus 3. We want to skip that 1, and we want to go to the next one, which is plus 4. Okay, so when you're looking at consecutive even numbers, it'll always go by 2s. Plus 2, plus 4, plus 6, plus 8, because that allows me to skip the odd, move to the even. Skip the odd, move to the even. Okay? Now, consecutive odd numbers, and this is the one that throws people off. If 5 is my x, okay, to go from 5 to 7, well, if I do x plus 1, I'm going to end up at 6. I don't want to end up at an even number. I want to skip that one and go to the next odd, which happens to be plus 2. And same thing with the next one. If I do plus 3, 1, 2, 3, I'm going to end up here on 8. That's an even number. I don't want that. I want to skip 8, and I want to go to 9, so I'm going to do plus 4. Okay, so the difference between consecutive even numbers and consecutive odd numbers, There is no difference here. They're both x, x plus 2, x plus 4. Okay, with the even numbers, I want to start even, skip the odd, go even, skip the odd, go even. With the odd numbers, I want to start odd, skip the even, go odd, skip the even, go odd. So the only difference here is that when I get my answer, this one here is going to be even, and here it's going to be odd. Okay, I would start on an even number, skip every other one. Here I would start on the odd number, skip every other one. Okay, other than that, they look identical. Okay, so consecutive integers goes up by 1, x, x plus 1, x plus 2, x plus 3. Consecutive evens and odds go up by 2, x, x plus 2, x plus 4. Notice that I leave x, I start with x on all of them. Okay, so then the sum of 3 consecutive even numbers where the first even number is represented by x. So they told me my first one. Okay, we want 3 consecutive even numbers. So my next one would be x plus 2, and the one after that would be x plus 4. Okay, because they wanted 3 of them, so add those together. X plus x is 3x. 2 plus 4 is 6, so 3x plus 6 would be the sum of 3 consecutive even numbers with the first one starting at x. Okay, so that's consecutive, even, and odd, and just regular consecutive numbers. You do need to understand those, so I highly suggest you study those a lot. Alright, so now we want to look at the problem-solving process. Okay, so I kind of laid it all out for you. Understand, translate, solve, and interpret. This first one we're going to walk through every step. After that, we kind of just do it intuitively because this is the natural problem-solving process. But this is just to make sure everybody has a method of attacking these things. So, the sum of twice a number and 7 is the same as 3 subtracted from the number. Okay, so the first part is the understand. First of all, I need to set a variable. So x is going to be my unknown number. Okay, because it talks about some number in here, and I don't know what that is. So I'm going to call that my unknown number. So there's my identified variable. Now after that, I need to break it apart. Okay, do these things piece by piece. That's how you work on any of these. Okay, whether I'm translating or solving. Break it up. So the sum of twice a number and 7. So I'm going to write that out, sum of twice a number. And again, we won't write this out every single time. Typically we'll just do a lot of underlining, but right now I'm going to write it all the way out. Okay, so how do I write sum of twice a number and 7? Well, twice a number is 2x. Okay, the sum means to add. So I want to add twice a number and 7. So this is going to be 2x plus 7. The sum of twice a number and 7. Okay, and then the next part is the same as, okay, that's going to be my equal, and then 3 subtracted from the number. 3 subtracted from the number. Okay? So this one you have to be very careful about. People tend to write this 3 minus x, but you can't. Okay? 3 subtracted from the number. Okay? Think about it as stealing something. If I want to steal something from you, well, you have to have it first. Okay? I can't take something from you if you didn't have it first. So to subtract 3 from a number, I have to start with the number to take 3 away from it. Okay, so I have to start with some number to take 3 away from it. So keep that in mind anytime, and that's a big key word. You need to recognize that. If I'm taking something from something else, you have to start with that something else. Alright, so then translate. So we have the pieces broken down, and we've got that the sum of twice a number and 7 is the same as, means equal in math, the 3 subtracted from the number. Okay, so then from there we just solve this. So if I take 2x plus 7 equals x minus 3, we're going to solve, so I'm going to subtract x. Okay, so that I move my x to the left. I'm also going to move my number to the right, so I'm going to minus 7. I'll do them at the same step. That way on the left-hand side of the equal sign, okay, so over here 2x minus x is just x. And then on the right-hand side of the equal sign, negative 3 minus 7 is negative 10. So x is equal to negative 10. Okay, but we do need to check this. That's the interpret part. Okay, we want to check this, so we're going to plug it back in. 2 times negative 10 plus 7 is equal to negative 10 minus 3. So negative 20, I don't know why I put an extra set of parentheses there, ignore that. Okay, negative 20 plus 7 is negative 10, and negative 3 is negative 13. So negative 13 equals negative 13, and that does check. Now there's a flaw with the checking. Okay, there is a flaw with the checking, and the flaw, I'm going to go ahead and write down my answer here. The number is negative 10. Now the flaw with this is that if I set my equation up incorrectly, okay, so say I wrote this wrong to start with, but I solved it correctly. So I wrote the wrong equation. Let's just say I did 2x plus 7 is equal to 3 minus x. And I solved this thing correctly. So I add x, and I get 3x plus 7 is equal to 3. So I go all the way through all the steps, and I get this as my answer. Okay? Now the problem is, and don't write this down because this is wrong. Ignore this. I'm just kind of giving you trying to show you. If I take this and I plug this back in here, okay, just like I did for this, now it's going to tell me I'm correct. Now the reason why it will check and say that it's correct is because I mathematically did this correctly. Okay, so if mathematically I can do it correctly from the wrong equation, well, I'm plugging back into the same equation that I made. So if the equation was wrong to start with, it doesn't necessarily tell me whether my answer is correct or not, which is an unfortunate part of this. Okay, but it can tell me whether or not I did my math correctly. So the fact that it checks in the end means that if my equation was correct, then my answer is correct. Okay, but if my equation was wrong, then my answer is also wrong. Okay, so be very careful there. Alright, so example 2, okay, and we're not going to do the step-by-step, but we are going to do the same sort of process. Okay, so twice the sum of a number in 4 is the same as 4 times the number decreased by 12, find the number. Okay, break it apart, don't look at it all at once. Twice the sum, and we've talked about this here. If I want to do twice the sum, okay, I don't want just 2 times the number, I want 2 times the sum of something. So I have to use parentheses. Okay, 2x is twice a number. They didn't ask for twice a number. They wanted twice the sum. Okay, well, the sum of what? A number and 4. Okay, so this is the sum of a number and 4, and we're multiplying that by 2. So twice the sum of a number and 4 is the same as, okay, 4 times the number. Okay, so that would be 4 times the number decreased by 12. So take 4 times the number and decrease it by 12. Take 12 away from it. That was ugly. Okay, so 4 times the number minus 12. Okay, then it says find the number. So don't just do that. It didn't say translate this one. It said find the number. So now we need to find the number. So now let's finish this off. So we distribute. 2x plus 8 is 4x minus 12. And then we subtract the 2x. Yes, I am going kind of fast, but you can always replay this if you didn't understand it. Okay, so I subtract the 2x from both sides to get 2x. I added the 12 from both sides to get 20. Okay, so 20 is equal to positive 2x. Divide that by 2. X is equal to 10. Okay, so again we can check. Okay, we can check this by plugging it back into our equation to see if it works first. 10 plus 4 is equal to 4 times 10 minus 12. So 10 plus 4 is 14. 4 times 10 is 40. I'm doing order of operations on both sides here. So we get 28 is equal to 28. So mathematically this checks. Okay, mathematically this thing checks. And I can also do this intuitively. So twice the sum of a number in 4. Okay, I know the sum of a number in 4 is 14. Okay, so 10 plus 4 is 14. Twice that is 28. Is the same as 4 times the number, so 40 decreased by 12, which is 28. So you can kind of do it intuitively if you have a hard time with the setting up equations to see if it matches up. Okay, so my unknown number is 10. Alright, so example 3, same sort of idea. Okay, only now we're going to look at those consecutives there. Okay, they're going to give us all kinds of information we don't even need. Some states have a single area code for the entire state. 2 such states have area codes that are consecutive odd integers. Okay, if the sum of these integers is 1208, find the 2 area codes. And I box this in because this is what I'm looking for, 2 area codes. Okay, so start off, we're going to identify, okay, I have consecutive odd integers. Okay, I don't know what the first odd integer is, so I'm going to call that x, and that's my first odd integer. Notice that I'm labeling here. Okay, and then I'm going to have, since it's odd integers, we're going to do plus 2 so that we skip the even and go to the next odd. Okay, remember, odds and evens you do plus 2, plus 4, plus 6, plus 8. So this is my second odd integer. Now from there they said the sum of these integers is 1208. Well, sum means to add. Okay, so I'm going to add x plus 2 is 1208. Okay, so the sum of those two numbers, whatever those numbers are, is 1208. So now we just solve. So 2x plus 2 is 1208. Subtract the 2. 2x is equal to 1206. Divide by 2. X is equal to 603. Okay, so we need to first go back. So the interpret part, make sure you're answering the questions. Okay, if this is where I stop, I lose points because it asks for 2 area codes. Okay, so the 2 area codes are, well, we said x was the first integer and it's 603. And we said the second integer was going to be the first one plus 2, so the second one is 605. Okay, so the check part, we don't really even have to check it back into this. We can do it intuitively. Okay, because it said that they are consecutive odd integers. 603 and 605 are consecutive odd integers. Okay, and the sum of these is 1208, so 603 plus 605 is equal to 1208. Okay, so it does check. Okay, so you really just need to kind of do it intuitively. Are they consecutive odd integers? So if I get like 603 and 609 to make it work, that doesn't work. They're not consecutive. They have to be in a row. Okay, so 603, 605, and they do add to give you 1208. Next part. This is kind of a long one, so I am gonna go kind of fast through them. Okay, but some of these are just repetitive. So the sum of 4 consecutive integers is 58. Okay, so 4 consecutive integers is 58, which you can always pause this and see if you can get the correct answer, and then come back. So the sum of 4 consecutive integers. So the first one is x. It's just consecutive. There's no even or odd. So I'm going to do each one. So plus 1, plus 2, x plus 3. Make sure you stop there. That's 1, 2, 3, 4 integers. The sum of those is 58. So let's add them up. 1, 2, 3, 4x. 1 plus 2 is 3, plus 3 is 6. It's equal to 58. Subtract your 6. 4x is equal to 52. Divide by 4. X is equal to 13. But don't stop there. Make sure you go back. Go back on every single word problem and double check. What did they ask me for? Find the 4 integers. Okay, so the 4 integers are 13, 14, 15, and 16. Okay, they were consecutive. I didn't have to do the jump. This was my first, plus 1, plus 2, plus 3. Okay, first, plus 1, plus 2, plus 3. Same thing here. Again, try to hit pause. Try to do this on your own. 3 consecutive odd integers this time is 75. I always start with x. Okay, just because it's odd doesn't mean anything. I'm going to do plus 2, plus 4. Well, it does mean something. It means I'm going to go plus 2, plus 4. Okay. Yes, these are even numbers, but remember, we're starting on an odd. Skip the even go to the odd. Skip the even, go to the odd. Add those up, and I get 75. Okay, find the three integers. So 1, 2, 3, x plus 6 is equal to 75. Subtract the 6. 3x is equal to 69. Divide by 3. X is equal to 23. See how my answer came out odd, even though I was using even numbers there? So x is 23, but they wanted 3 consecutive odd integers. So if x is 23, the next one is plus 2 is 25, and 23 plus 4 is 27. 23, 25, 27. 3 consecutive odd integers. Okay, so now we've also done something similar to this, only we didn't solve last time. So a 10-foot board is to be cut into 2 pieces. So here's my board. Okay, we're going to draw our cute little board here. Let's make it a little three-dimensional just because. Why not? So there's my board. Okay, so I've got my board. I'm going to take that board and I'm going to cut it into 2 pieces because that's what they told me to do. Okay, so there's my cut. Cut it into 2 pieces. Now, the longer piece is 4 times the shorter. Okay, so they tell me that the longer piece is 4 times the shorter. Well, I don't know what the short piece is, so I'm going to call that x. So x is my short piece. Yes, you do have to label these when you take your test. So x is my short piece. So then my longer piece is 4 times the short piece. Okay, well 4 times my short piece is x. So 4 times x is my long piece. Together, I know those things are a total length of 10 feet. Okay, so if I add those 2 pieces back together, I should get a total of 10. So 5x is equal to 10. Divide by 5, divide by 5, x is equal to 2. Yet again, look at what it's asking you. Find the length of each piece. Okay, we need to use our unit. So my short piece here is 2 feet. That's what I just found because that was my x. Okay, and then my long piece was 4 times that. So 4 times 2 is going to be 8 feet. Now double check that. Okay, together they make 10 feet. Yes, they do. Okay, and the long piece is 4 times the shorter. Yes, it is. 2 times 4 is 8. Okay, so make sure these things make sense. Check them. Always check them. All right, Hertz Car Rental charges a daily rate of $39 plus 20 cents per mile for a certain car. Suppose that you rent that car for 3 days and your bill is $180. How many miles did you drive? How many miles? So there's what I'm looking for. I'm looking for how many miles. Okay, which that means that's going to be my variable. So M is going to be my number of miles. Okay, it's typically always going to be what I'm looking for. That's my unknown. That's why it is my unknown, because that's what I'm trying to find. So I'm going to use M this time. So M is going to be my number of miles. Now when you're setting these up, the biggest thing that you have to do is match the rate to its unit. Okay, so what do I mean by that? Well, I have a daily rate of $39. Okay, and I have 3 days. So that would be my rate with its unit. So $39 for 3 days would be 39 times 3. Okay, rate and unit. Okay, I also have 20 cents per mile. Okay, so that's my rate. 20 cents per mile, so 0.2 times my unit. Well, my unit would be miles. Okay, but I don't know my miles, so we're just going to call it, sorry, I don't need a parenthesis. We're just going to call that M. Okay, rate and unit. Okay, this would be my miles. I just don't know how many miles yet. So then it says that my total bill here is $180. So when the cost here for each day plus the cost for each mile should give me a total of $180. So from there, I just have to work that out. Okay, so you get 39 times 3, which is just 117, plus 0.2 times n, 0.20, sorry, those should really be 0.20, although the 0 is not necessary. So that's 180. So now we just got to finish subtracting, solving. So subtract the 117, so 0.20m is equal to 63, divide by 0.20, and I get m is equal to 315. Okay, so my answer there, how many miles did you drive? I drove 315 miles. Okay, now you don't necessarily have to do the I drive part, but you do have to do the unit. So 315 miles is my answer. Make sure your units always match up. Alright, so if the two walls of the Vietnam Veterans Memorial in Washington, D.C. were connected and isosceles triangle would be formed, the measure of the third angle is 97.5 more than the measure of either of the other two equal angles. Notice it says equal. Find the measure of the third angle. Okay? So I'm trying to find the measure of the third angle. Well, first I'm going to draw a picture. So an isosceles triangle, they say they're equal angles, and that's because an isosceles triangle has two equal sides. Okay, so those two sides are the same. Now it also says that they have equal angles because these two angles here will also be the same. Okay, now it says the measure of the third angle is 97.5 more than the measure of either of the other two equal angles. Okay, so I don't know anything about the equal angles except for that they're equal, so I'm going to call them both x. Okay, so each one of those is going to be x degrees. Okay, which makes this one 97 more than that, so x plus 97.5. Okay, so 97 more than the measure of either of the other two, so there's your x plus 97.5. Now, one thing you do have to know is that the sum of interior angles of a triangle is equal to 180 degrees. Okay, so that means I can take all three of these and I can add them up, and what's going to happen is I'm going to set them equal to 180 because x plus x plus x plus 97.5 has to equal 180. So I get 3x plus 97.5 equal to 180. Subtract your 97.5. I get 3x is equal to 82.5. If I divide by 3, I get x is equal to 27.5. Okay, but this is not my answer. So 27.5 was the size of x. I wanted the measure of the third angle. Okay, so then I'll go do it right here. So the third angle would be 27.5, which is my x value, plus the 97.5, okay, which is going to equal 125 degrees. So my third angle is 125 degrees. Okay, so again, be careful. Go back. Make sure you look at what they're asking for. If you just stop at x all the time, most of the time you're not going to have the correct answer. You need to actually go and figure out what was that x and what are they actually asking for. So make sure you're always going back and double checking those things. Okay, so that was the end of 2.4. Now we need to do 2.5, which should go pretty quickly because 2.5 is just a matter of using equations or formulas rather. Okay? So a formula is just an equation that describes a known relationship. Okay, so everything else, it's kind of been arbitrary relationships. Okay, we've looked at 3x plus 5 equals whatever. So that's an equation, and it does show a relationship. Okay, but it's not like a known relationship to everybody. These formulas are going to be relationships that show up across the world. Everybody knows the area is length times width when you're talking about a rectangle. So that's just the difference between an equation and a formula. Formulas is something that's universal. Okay, so for example, whatever we're doing these, all we have to do is find the correct, identify what my variables are, identify what they're telling me, and then choose the proper formula. So the approximate distance from Mobile, Texas to San Antonio, Texas is 215 miles. If I drive at a rate of 65 miles per hour, how long will it take, okay, to drive to San Antonio? So look at what they give me. I've got some distance, I've got a rate, I'm looking for time. So the one that's distance equals rate times time, that would be the formula that I want to use. Distance is rate times the time. And then part of this to understand, we're going to identify all of the variables that I know. So they tell me that distance is 215 miles. They also tell me that the rate is 65 miles per hour. You do have to make sure that your units match up. So for instance, if this was in kilometers and this is miles per hour, then you have to do a little converting first. Okay, but this is the same. We got miles and miles, which means that my time is what I'm looking for, and when I get it, it will be in hours because this is miles per hour. Okay, so then the translate, we're going to take those numbers and plug them in. So 215 is equal to 65t. Divide by 65. Okay, so when you do that, that's part of the solve. We're on to the solving step now. Okay, we get that t is equal to 215 over 65, which is it's approximately, let me rephrase that. So you're going to use the little, what you guys tend to call the squiggly equal signs, which actually means approximate. So t is approximately 3.31 hours. Okay, so the interpret part is just making sure that seems reasonable. Okay, a little under 3.5 hours to drive in San Antonio sounds pretty reasonable. I don't have negative time, and it's not extremely large or anything like that. So it's a reasonable number. I could always plug it in, or I could always check it by multiplying it back. So if I did 3.31 times 65 miles per hour, I will get approximately 215 miles. Now, it's not going to be exact anymore because I rounded my time. So, my final answer will be approximately 3.31 hours. Sorry, not miles. I already have miles. Okay, so that would be my final answer. Approximately 3.31 hours. Okay. So here's another one. This one's just got perimeter. So Charles can afford enough fencing to enclose a rectangular perimeter of 140 feet. The width of the garden is must be 30 feet. Find the length. So I'm looking for length. Okay, so I'm going to go up and I'm looking for the rectangular perimeter. Okay, so here's the perimeter of a rectangle, which is going to be 2 times the length plus 2 times the width. That's an L. It's an ugly L, but it's an L. Okay, so 2 times the length plus 2 times the width is what I'm looking at. They tell me my perimeter is 140 feet. They tell me my width must be 30 feet. Okay, so you're just going to plug those in. If you want to, you can draw a picture. You don't have to. But I have a total of 140 here, and I know that these are both 30. Okay, so plug that in. 140 is 2 times the length plus 2 times the width. So 140 is equal to 2L plus 60. Subtract the 60 over. Okay, so 140 minus 60 is going to be 80. It's equal to 2 times the length divided by 2. And my length is 40. That's a length, not time. Length is 40 feet. Okay. Okay, 40 feet. Make sure you put that unit on there. You have to have length is 40 feet. Okay, so you can double check that. Okay, if that means that this is, when I label it out on my picture here, those should both be 40. 40 and 40 is 80. 30 and 30 is 60. 80 and 60 makes 140. So it does add up to 140 for the perimeter. So that works. Now, this next one is really, it's the same sort of thing. So the average maximum temperature in January in Algeria is 59 degrees Fahrenheit. Find the equation temperature, find the equivalent temperature in degrees Celsius. So I'm going to use the Fahrenheit to Celsius and Celsius to Fahrenheit equation. So we get Fahrenheit is 9/5 of Celsius plus 32. Okay, so that's my equation, and it's on the other sheet, so if you need to, flip back over and look at that. This is 59 degrees Fahrenheit, so I know that F is 59 degrees. Okay, so we're just going to plug that in. So 59 is 9/5 of C plus 32. Now we're going to solve for C, so subtract 32. So I would get 27 is equal to 9/5 c. Now remember, to get rid of a fraction like that, we can just multiply by the reciprocal, so multiply by 5/9 on both sides. So those go away. I end up with c on the right hand side. 5/9 times 27. You can use your calculator. I'm just going to reduce. 9 and 27 reduces to 1 and 3. So 5 times 3 is 15. So I get 15 degrees Celsius. Okay, so 59 degrees Fahrenheit is the same as 15 degrees Celsius. Okay, very last part is solving equations for a specific variable. Okay, so sometimes when we have our formulas, we want you to solve for a specific variable without using numbers. Okay, if you look at the steps look the same as they have been for all of my problem solving. Okay, we're going to start with distributive property to get rid of parentheses. We're going to combine like terms on each side if they exist. Combine all terms containing the specific variable on one side and all other terms on the other side. So this is the only place where it's different. Before, we moved all our variables to one side and all our numbers to the other. Now we're going to find the term that has the variable we're trying to solve for. That's going to go to one side, and all the other terms are going to go to the other side. Okay? And then you're going to get it alone by using that multiplication property. So, for instance here, we don't even have parentheses, so no step 1. There's no like term, so no step 2. This one says we got to use the additive property. We don't even have anything added or subtracted here, so we're going to skip step 3, go all the way down to multiplication. This means L times W times H. So if I want to solve for L, that means I'm trying to get L equals something. Okay? So I need to get rid of W and H. L times W times H. To get rid of multiplication, we just divide. So divide both sides by W and H. So those will cancel. Okay, and I've got V divided by WH is equal to L. And that's all it is. That's all you do. I have L equals. That means I have solved for L. Okay, so same thing with example 5. Okay, I want to solve for X this time. So here's the term that has my X value. Okay, so before I can do anything with this, step 3 says I need to use the additive property. Remember, that means subtraction also. Okay, so plus B, I'm going to subtract B from both sides so that that goes away. So I get Y minus B is equal to M times X. Now we're on the last step. I want X to be by itself because I'm trying to solve for X. So I'm going to get rid of M by dividing. I have to divide the entire left-hand side, so be very careful that your handwriting doesn't get in the way and lose you points here. Okay, that fraction bar has to go all the way across. So my final answer here would be X is equal to Y minus B over M. I just switched directions here. Y minus B over M equals X is the same thing. Okay, so that's solving for X. I've got X equals. Okay, hit the pause button, try that on your own, come back, see if it matches. There's the term I'm trying to keep by itself, so I'm going to move this part first. This is a positive 2L, so I'm going to subtract 2L from both sides. What I do to one side of an equal sign, I do to the other side of an equal sign. So P minus 2L is 2W. And then I want to get rid of this 2. This is 2 times W, so to get rid of the 2, we just divide. So W is equal to P minus 2L, all divided by 2. And that's my answer. I can't cancel or reduce anything because this P is also being divided by 2, so you can't just get rid of those 2. So just leave it alone. That would be my final answer there. And that's the end of the Unit 2 notes. Good luck with that.